Hey there, ladies and gentlemen. Welcome to my basement. This is the Bourbon Nation. We are talking about some math on 7-2. This is day 1 of 7-2. The way that this process works is we're going to look at division with exponents. So 2 to the 5th is just 2 times 2 times 2 times 2 times 2. And 2 to the 3rd is 2 times 2 times 2. So the way that we can work through this is by simplifying with division. So 2 divided by 2 makes 1. 2 divided by 2 makes 1. 2 divided by 2 makes 1. Now there are no longer more 2's on both the top and the bottom for me to divide out to simplify things. So this is where we're just done. So you'll notice that there's just 2 2's left on the top. So when I simplify this, the answer becomes 2 to the 2nd power on top. All 3 of those have been canceled out. So it's just this for an answer. So the math behind that is that when we are dividing exponents, the quotient of powers rule means that we're going to subtract their exponents. Because if you look up here, we did 5 minus 3 makes that 2. Don't mind my kids, they're just playing with the dog. That's how this kind of works out. So you're just subtracting the exponents. This was 2 to the 5th minus 2 to the 3rd. That's where 2 to the 2nd came from. So that's the big idea. Here's a couple more examples of how that looks. 7 minus 3 makes a k to the 4th. 6 minus 1 makes an m to the 5th. So it's a fairly simple idea. We just have to make sure we can recognize when to use it. So here's a couple quick examples. 7 minus 2, I get a g to the 5th. 15 minus 9, I get a g to the, whoopsies, to the 6th. I'll make a 6 there. Yeah. When there's more letters, it's the same process. Just have to make sure we match our letters. So I can do m's minus m's and n's minus n's. So I'll have a 6 minus 2, which makes an m to the 4th. And 8 minus this 1 that's not there, we'll make an n to the 7th. On the second one over here, an x to the 9th minus an x to the 7th makes an x to the 2nd. A y to the 4th minus a y to the 1st makes a y to the 3rd. A z to the 7 minus a z to the 6 makes a z to the 1st. You can put the 1, but you don't have to put the 1. Normally I don't, but just to make sure that you guys understand everything, I'm putting that there. Next rule we have is if we have a division problem or a fraction that's to a power, both pieces or all pieces of the fraction get that power. So again, that's another rule for us, a power of a quotient. If you have a fraction that is being given to some sort of an exponent, all pieces get it. So here's more examples of how that looks. If we have 2/5 to the 4th power, that means I have 2/5 times 2/5 times 2/5 times 2/5. So the really long way of writing it would be this. And if I look at only tops, that means this 2 got to the 4th power. And if I look at only bottoms, that means that 5 got to the 4th power. And that's what you see up here. So we can go straight from here to this number here by just using those kinds of patterns. That's the cool thing about math, is when we see the patterns, we go through them and recognize them and just go a little bit quicker. So same idea here, this 5 gets to all pieces of the fraction. So we have a 1 to the 5th over an 8 to the 5th. You would take your calculator and actually do that math. Let's keep moving here. So here's our play time. This 3 goes to all pieces of the fraction. So we have a 3 to the 3rd power that we're going to do. We have x to the 4th to the 3rd power, and then a 2 to the 3rd power. So all we have to do now is just simplify all of that math. 3 to the 3rd power means 3 times 3, which is 9, times 3, which is 27. So I have a 27, and then we have a power to a power, which is what we learned on the last lesson, which means we multiply, so we have an x to the 12th. On the bottom one here, we have a 2 times 2 times 2, which is an 8. And if we could, we would, but since we can't, we won't. we would simplify here. So if this 8 worked nicely with the 27, we would simplify that fraction, because it'd be like this. We'd have like 27 over 8 and then x to the 12. So we would simplify that fraction if we could. All right, now I need to pause here because I got some kids moving. All right, so I'm back now. Oh, you want to get down now? Okay. The next problem is the same exact idea. Again, you guys can hit pause whenever you need to. But we're going to take this to the 4th power, and it goes to the coefficient, it goes to the x's, to the y's on the top, it goes to the 6 on the bottom, and to the z's on the bottom. So as we rewrite this, this would be 5 to the 4th power times x to the 5th to the 4th power, and times y to the 1st to the 4th power. All of that is going to be over a 6 to the 4th power times a z to the 2nd to the 4th power. So then it's up to us just doing the math. Now you might have a calculator to do this. If you don't, you have to do a repeated multiplication. I have one of those cute calculators from school. So I'm just type in 5 to the 4th power, which is 625. So now I have a 625, x to the 5th to the 4th. Remember, a power to a power means multiply, so now I have an x to the 20th, and then a y to the 4th when we do 1 times 4. All of that is going to be over 6 to the 4th. I don't know that one off the top of my head. And because I got the little kids running around, I'm going to do a calculator math. That makes a 1,296. And then a z to the 2nd to the 4th, we multiply again, so we have a z to the 8th. Now the last thing I check is that these numbers can be simplified, or that my letters can be simplified like we did in our very first examples. So I'm just going to take my calculator and do 625, hit the fraction button over 1296 and see if it simplifies. It does not, so we're going to leave it alone. So that's always a nice, awesome thing. This whole problem is then done. So here's a couple more examples of the same exact kind of stuff. This to the 5th goes to each piece. So one way to write down all of your work is to go 2 to the 5th, y to the 2nd to the 5th, a 3 to the 5th, a z to the 3rd to the 5th, and then just do the math. Now I wrote pretty sloppy because I'm trying to be quick for you guys, because I don't want to take your entire day away. Take your day away. All right, so 2 to the 5th is 32. Y to the 2nd to the 5th makes a y to the 10th because we use our multiplication due to the rule from last lesson. 3 to the 5th is a 243, and then a z to the 3rd to the 5th, we multiply, so we got a z to the 15th. Now 32 over 15 is not going to play nice, I'm pretty sure, of 243, sorry. And it doesn't, so then this is your final answer. And here's our last problem of the day. And then again, we're looking at these numbers. So you have a 2 to the 2nd. Each piece gets to the 2nd, because that's the rules. And then over 3 to the 2nd and n to the 2nd to the 2nd. So we're going to use our multiplication rules. This makes a 4. This one makes, because we multiply 2 times 2, we get a 2 to 4. That one makes a 9. N to the 2nd of the 2nd makes an n to the 4th. Now none of those numbers work nice together, so we just circle it and we're done. So that's how this stuff works out, folks. Your assignment's on Schoology. If you have questions, make sure you reach out and ask for help. Otherwise, I can't help you if you don't say you need the help. I'll just see your score is either good or bad, and then we're going to keep moving. So this is the Burma Nation. I'm signing off. Stay safe, folks. Bye-bye.